So, if you did the 2.2 run in PE here, yeah, we remember those, right? What is your total distance traveled if you do that? Yeah, the total distance traveled would be like 2.2 miles. Okay. What is your change in position, which we also call displacement? 0. Because you started and you ended at the same place. And so notice that's the difference between these two ideas then. Distance traveled includes all of that random little path that you might take in order to get someplace. And it's covering basically how far did you have to walk, run, whatever it was. Whereas when we come to displacement is just basically saying, look at point A, look at point B. How far apart are those two? And that's it. Now when it comes to our integrals that we've been talking about recently, for this setup here, if we were asked for the change in position between T1 and T2 here, basically, I could, in order to find distance there, because this is a velocity graph, I would do the integral. Okay, and it's just the area under the curve. So this would tell me what that distance is. The distance traveled from T1 to T2 in this case would be the same. Because the distance traveled here is also going to just be the area under the curve. But that's because this one's set up kind of nicely, because we're going between this T1 and this T2. But what about this? When we look at this situation, the change in position from T1 to T3. Well, notice from here to here, it's all positive. From here to here, it's negative. So positive velocity, negative velocity. Basically what we're looking at here is that up here, we are moving away from where we started, but then down here, we're moving back toward where we started. If I'm looking at the change in position from T1 to T3 then, what would I actually be doing? Well, just change in position, well, we could just do the integral still, because it means that we take this area and we take this area away from it. The negative area actually comes into it, and that's what we want, because basically all we're interested in is just from the start to the finish, what was the total distance traveled. Like, actually I should say that differently. Not total distance traveled, but total difference like between where we started and where we ended. That's all we care about. Whereas if we are interested here in distance traveled, it's got to be a little bit different. Because if we're talking distance traveled, in here, I was traveling away from where we started. And down here, I'm traveling back toward where we started, but I'm still traveling. I want that added on. Because distance traveled here is basically, what is that whole route that I walked or ran, the whole random thing. And so instead, what we end up having to do here is we end up doing the integral from T1 to T2 plus the absolute value of the integral from T2 to T3. In other words, when we talk distance traveled, there can be no such thing as a negative distance. Everything ends up being a positive. And so we end up actually having to then do a couple different problems all in one here. Now, when it comes to actually doing the work to do these, though, it means that since that changes from positive to negative anytime we cross the x-axis, it means we're going to have to be able to figure out where the zeros are in any equation where we're looking for distance traveled. All right? Now, we're actually going to put that into action here. So here's an example problem. We got a particle moving along a line with the velocity represented by this equation. We're going to find both. We're going to find both the displacement and we're going to find the distance traveled, but starting just with displacement here. So we want to know what the displacement of the particle is in the time period from 1 to 4. All right, so if I'm going to find that displacement then, I really am then doing the integral. And since it's for this specific time period from 1 to 4, that means I'm going to take my integral from 1 to 4, making it a definite integral, of my v of t function. Now that means I can go ahead and plug in what v of t equals. So it's going to be the integral of t squared minus t minus 6. And then, remember, we always have to end it with the dx, or in this case, dt. So this is what we're actually doing to solve this. The first thing you need to do is figure out what your antiderivative is. So we're doing capital F of t. And then we're finding our function values, our antiderivative values, at our two numbers. So at 4 and at 1. And so we get our two values. We're getting f of 4 at negative 10 2/3, and then we get f of 1 as being negative 6 1/6. Then the last thing we need to do in order to find that displacement, in other words, to find that definite integral, is we need to do the f of 4 minus f of 1. Remember, it's always top minus bottom there. And we get about negative 4.5. Now, in this particular case, though, I don't want to just leave it as negative 4.5 as my final answer. Remember up here, it was measured in meters per second. And so this answer then, the displacement, what are my units? Well, the original was velocity. This is distance. So it's just going to be the meters. So it's negative 4.5 meters. All right, now we're going to be doing distance traveled. Distance traveled is going to be a bit more work. Because in order to find distance traveled, the very first thing I need to do is I need to figure out if, during the same time period, because notice it says during the time period, it's referencing the same 1 to 4. During that time period, does this graph ever cross 0? And so in other words, does it ever change between positive and negative? And so we actually need to check that. And so in order to check that, I'm going to take my original function, my v of t, and I'm going to set it equal to 0. So t squared minus t minus 6, and I want to see where does that happen, and what t values do we actually hit 0. Well, thankfully this is a quadratic and not something much more complicated. We can go ahead and solve this one by factoring. And so we end up finding that here t could be a positive 3 or negative 2. Those are the two values at which we actually hit 0. Now remember, the time period that we're looking at in this particular problem is between 1 and 4. So what really interests me then out of this particular situation is the t equals 3. The negative 2 is outside of my particular range that I'm looking at, so I'm not going to worry about it. And so what that means for us is that if I'm actually going to find the distance traveled, that means I'm going to have to do the integral from 1 to 3 of my v of t. And I'm going to have to do the integral from 3 to 4 of v of t. And I need both of those to be positive. Now, I could kind of figure out from the graph ahead of time which one of those is going to be positive. But just to make it safe side, I'm just going to say, I'm going to take the absolute value of both of those. And then I'll add them up together. So this is what we're really doing here, is we find each of those integrals, so the integral on each side of where the 0 is, make sure they're both positive, and then we add them up together. And so with that in mind, that means I need to know what is f of 1, f of 4. Now the nice part is, from the last problem, I already did those, right? So I'm actually going to be able to just grab those numbers and reuse them. But I'm also going to have to figure out what f of 3 is in order to do that. All right, so now I can actually do these integrals. And I have to actually do the integral first before I do the absolute value. So the integral from 1 to 3 is going to be f of 3 minus f of 1. So we get negative 7 1/3 for that one. And then we go and we do the same kind of thing. This time we're going to go ahead and do the integral from 3 to 4 of v of t. And so for that calculation, we end up getting 2 5/6. Now we can actually go ahead and finish this one out. So you notice that when I did that, one of them ended up being negative. Well, that tells me that's the one I ended up having to make positive when we go ahead and we do this. Because in order to find that total distance traveled, I'm going to now do the 7 1/3 positive plus the 2 5/6. And so when we do that, we then should get 10 1/6. And again, think about units, because this is actually talking about the distance traveled. So that's going to be 10 6 meters. Units are going to be the same on this one and the last one, since they're both talking distances.